Look at a map of the world. London, Paris, Berlin. These vibrant European cities share the exact same latitude as the frozen, desolate tundras of Canada and Siberia. So, why isn't Europe buried under miles of solid ice? The answer doesn't come from the sun. It comes from the deep, dark ocean. Right now, beneath the surface of the Atlantic, a silent, massive underwater river is flowing. It is a global conveyor belt of heat, the very heartbeat of our planet. Scientists call it the AMOC. It keeps Europe warm. It controls the monsoons in Asia. It dictates the survival of billions. But there's a terrifying problem. This heartbeat is slowing down. For the first time in over 1,000 years, the AMOC is approaching a total collapse. And if it stops, the consequences will be immediate and catastrophic. Europe will freeze. Global weather systems will shatter. And the Earth as we know it will be gone. How did we get here? And more importantly, how much time do we have left? To understand the threat, we have to understand the machine. Think of the Atlantic Ocean as a giant global engine. In the tropics, the sun heats the surface water. This warm water travels north, towards Greenland and the Arctic, carrying immense heat with it. But as it travels, the water gets cold. And because it is ocean water, it is packed with salt. Cold, salty water is heavy, extremely heavy. So, it sinks. Millions of cubic meters of water plunging into the abyss every single second. This massive sinking motion acts like a vacuum, constantly pulling more warm water up from the equator. It is a perfect, delicate loop, the AMOC. But human activity has introduced a fatal flaw into the system. Ice is melting. Billions of tons of fresh water from Greenland's glaciers are pouring into the North Atlantic. Fresh water isn't salty, it isn't heavy. So, the water stops sinking, the vacuum breaks, and the world's most important engine begins to choke. We hear that Greenland is melting, but human brains are not wired to comprehend the sheer scale of what is actually happening. Greenland is not just a snowy island. It is a landmass covered by an ice sheet that is up to 3 kilometers thick. It contains enough frozen water to drown every coastal city on Earth. But the immediate danger isn't the rising sea level. The immediate danger is the fresh water. Salt water and fresh water do not behave the same way. Salt water is dense, it is heavy, it wants to sink. Fresh water is light, it wants to float. Right now, under the heat of a warming atmosphere, Greenland is hemorrhaging fresh water into the North Atlantic. We are not talking about a slow drip. We are talking about massive, raging rivers of sapphire blue meltwater carving through the ice, plunging down vertical shafts, and blasting out into the ocean. A recent study revealed that Greenland is losing an estimated 30 million tons of ice every single hour. 30 million tons an hour. This creates a massive freshwater cap on the surface of the North Atlantic. It acts like a suffocating blanket over the AMOC. When the warm, salty water arrives from the tropics, it meets this massive layer of light, fresh water. It cools down, yes, but because it is suddenly diluted by the fresh water, it never becomes heavy enough to sink. The vacuum is destroyed. The downward plunge stops. The terrifying reality of the AMOC is this. We don't need all the ice in Greenland to melt to trigger a collapse. We only need just enough fresh water to tip the balance of density. And every single hour of every single day, 30 million tons of that tipping point is pouring into the sea. We don't just have to rely on computer models to know what happens when the AMOC collapses. We know. Because it has happened before, we have to go back 12,000 years. The Earth was just beginning to warm up, emerging from the last major ice age. Glaciers were retreating. Life was flourishing. But then, in the blink of a geological eye, the warming abruptly stopped. Temperatures in the northern hemisphere plummeted by up to 10 degrees Celsius. The ice advanced once again. Whole ecosystems were devastated. Scientists call this terrifying chapter in Earth's history the Younger Dryas. For decades, the cause of this sudden freeze was one of the greatest mysteries in geology. What force was powerful enough to reverse global warming in a matter of years? The answer lay buried deep in the ice cores of Greenland. As the Earth had warmed, a massive glacial lake in North America, Lake Agassiz, had grown to the size of the Black Sea. It was held back only by a dam of ice. Eventually, that ice dam broke. Trillions of gallons of freezing fresh water surged into the North Atlantic Ocean in a colossal mega flood. It was a fatal injection. This massive influx of fresh water instantly diluted the salt content of the ocean. The heavy water stopped sinking. The conveyor belt ground to a violent halt. The AMOC shut down. Without the equatorial heat flowing north, Europe and North America were plunged back into a brutal 1,000-year winter. This isn't a theory. It is written in the stone, the ice, and the fossil record of our planet. But 12,000 years ago, it was a natural glacial lake that triggered the collapse. Today, we are the trigger. The Greenland ice sheet holds enough fresh water to raise global sea levels by 24 feet, and right now, it is melting at a rate of 30 million tons every single hour. We are recreating the Younger Dryas, but this time, billions of human lives are in the crosshairs. So, what happens when the engine actually stops? We used to think a collapse would take centuries, but new data suggests it could happen terrifyingly fast. If the AMOC shuts down, Europe would plunge into a deep freeze. Average temperatures across the UK and Scandinavia could drop by up to 15 degrees Celsius. Imagine winters so brutal, modern infrastructure simply cannot cope. Agriculture would collapse. Rivers would freeze solid. But the nightmare doesn't stop in Europe. The AMOC is a global system. Without the current pushing warm water north, all that heat gets trapped at the equator. The entire global rainbelt would shift southward. The Amazon rainforest, the very lungs of our planet, would be deprived of rain. It would face catastrophic droughts, rapidly turning from a lush, life-sustaining jungle into a dry, barren savanna. Meanwhile, the water that is no longer moving north has to go somewhere. On the east coast of the United States, water would begin to pile up. Sea levels would rise drastically and suddenly, devastating cities like New York and Miami long before global warming melts the poles. This is a domino effect. One system falls, and it takes the rest of the planet down with it. The most terrifying question isn't what will happen. The most terrifying question is, when? We often think of an AMOC collapse as a European problem, a story of snow, ice, and freezing cities. But the true catastrophe will be born in the heat. The AMOC doesn't just move warm water north. It acts as an anchor for the entire global weather system. Specifically, a critical system known as the Intertropical Convergence Zone, or the ITCZ. Think of the ITCZ as a massive continuous band of heavy rain that circles the Earth's equator. This single rain belt dictates the summer monsoons in India. It waters the vast agricultural plains of West Africa. It is the lifeblood of South America. Over 3 billion people rely on this exact weather pattern to grow their food. But if the AMOC shuts down, the northern hemisphere cools rapidly, and this drastic temperature change will forcefully push that entire global rain belt south. The consequences: instant, unprecedented drought. The monsoon seasons that India and West Africa depend on would fail. Year after year, rivers would run dry. Crops would wither in the fields before they could be harvested. We are not looking at a gradual decline in food production. We are looking at an immediate, synchronized global crop failure. In a world that is already struggling to feed 8 billion people, the sudden loss of the equatorial harvest would trigger famines on a scale never before recorded in human history. Global supply chains would shatter. The price of basic wheat and rice would skyrocket overnight. And history tells us, when food runs out, civilization fractures. We are treating the Atlantic Ocean like an isolated body of water. But it is the motherboard of the global climate. If you break the motherboard, the whole system crashes. In 2023, researchers from the University of Copenhagen published a study that sent shockwaves through the scientific community. By analyzing over a century of ocean temperature data, they didn't just confirm that the AMOC is weakening, they gave us a timeline. Their models suggest that a full collapse might not be centuries away. It could happen anywhere between 2025 and 2095, with the most likely tipping point occurring right in the middle of this century. Rivers would run dry. Crops would wither in the fields before they could be harvested. We are not looking at a gradual decline in food production. We are looking at an immediate, synchronized global crop failure. In a world that is already struggling to feed 8 billion people, the sudden loss of the equatorial harvest would trigger famines on a scale never before recorded in human history. Global supply chains would shatter. The price of basic wheat and rice would skyrocket overnight. And history tells us, when food runs out, civilization fractures. We are treating the Atlantic Ocean like an isolated body of water. But it is the motherboard of the global climate. If you break the motherboard, the whole system crashes. In 2023, researchers from the University of Copenhagen published a study that sent shockwaves through the scientific community. By analyzing over a century of ocean temperature data, they didn't just confirm that the AMOC is weakening, they gave us a timeline. Their models suggest that a full collapse might not be centuries away. It could happen anywhere between 2025 and 2095, with the most likely tipping point occurring right in the middle of this century. This means we are not talking about a distant threat for our great-grandchildren. We are talking about a catastrophic shift happening within our own lifetimes. Scientists are still debating the exact dates. Some argue the models are too aggressive. But the underlying truth remains undeniable. The engine is struggling. The Earth is alive. It is massive, powerful, and entirely indifferent to us. If we push the system too far, the system will push back. To survive the changes coming to our world, we must first understand them. Thank you for watching. If you want to uncover more of our planet's hidden truths and terrifying realities, subscribe to Terrum. Until next time, keep watching the horizon.